calcium isn't just holding your plant together. That isn't even half of the story. Calcium is how your plant thinks. And once you understand exactly what calcium's doing inside your plant, not in the xylem or in the nutrient solution, but inside the cell, you'll never look at plants the same. That's a promise I don't take lightly. So let's go. Everything you've learned about calcium before this video certainly isn't wrong. Calcium is a structural building material. It's the primary component of cell walls. It really is the stuff that holds plant cells together and gives them rigidity. Without it, your cell walls are going to be weak and your stems are fragile. Your fruit doesn't really hold together properly. You've seen this, blossom and rot on tomatoes or tip burn on lettuce. These are real calcium deficiency symptoms, and they're real problems. And for most of plant science history, that was the whole story. Calcium builds things. Make sure you have enough. Moving on. But the thing about incomplete stories, they're not wrong, they're just not finished. And the part of the calcium story that nobody finished telling you, well, that's what changes everything. Because when the plant invites calcium into the cell, into the cytosol, well, this is where the real magic happens. Cytosolic calcium does one of the most amazing things in all of nature that triggers a system that honestly makes our nervous system seem simple. But before we get into the real magic, let's talk about what calcium is before it does anything at all. In its elemental form, straight off the periodic table, calcium is just a metal. It's soft, reactive, nothing really remarkable. You really wouldn't even recognize it as anything useful. But something happens when calcium dissolves in water. It loses 2 of its 20 electrons. And when it loses those 2 electrons, it becomes something completely different. It becomes calcium 2 positive. A calcium ion. Now it's carrying a positive charge of 2 and has a whole new identity, a new set of properties, a new role in the biological world. And this matters because your plant can't use calcium in its elemental form. And if you've been following this channel for long enough, then you know that plants absorb nutrient ions. They don't absorb nutrients, dirt, anything else. So this transformation is certainly not unique to calcium. But what is unique to calcium is what it does next. See, calcium 2 positive immediately does something that sets it apart from almost every other nutrient. It takes a totally different path through the plant. Ca2 positive moves through the xylem, passively, on the transpiration stream. Remember the transpiration pool from the last video? That unbroken chain of water molecules being pulled from the roots to the leaves by the thirst of the air? Well, calcium 2 positive is riding that stream, which means, and this is the first practical growing tip I'm going to give you in this video, calcium delivery is not a nutrient problem, it's a transpiration problem. Dial in your transpiration pool and you dial in your calcium supply to every growing tissue in your plant. If you let your VPD drift, let your transpiration slow, and calcium delivery is going to slow with it, regardless of what's in your reservoir. So now we have calcium 2 positive riding the transpiration stream, arriving at the cells through the plant, doing its structural job in the apoplast, that's the space outside the cell membrane. But inside the cell, something completely different is happening. And to understand it, you need to know one specific fact that changes everything. Your plant is actively keeping calcium 2 positive out of the cytosol. Every cell membrane has specialized pumps whose entire job is to remove calcium 2 positive from the cytosol the moment that it gets in. They push the Ca2 positive back out through the membrane. They run continuously, and they burn the plant's own energy just to maintain that almost empty cytosol. It never stops, because the moment it does, calcium would flood in and fire a signal whether the plant wants it to or not. The resting concentration of calcium inside the cytosol of a healthy plant is somewhere around 100 to 200 nanomolar. The concentration outside that cell can be 10,000 times higher. 10,000 times. Your plant is maintaining that gradient on purpose, burning energy to maintain it, because that gradient, that almost empty cytosol, it's not a storage problem, it's a loaded gun. When the cytosol is almost completely empty of calcium, a signal stimulus, it can flood in fast and dramatically and unmistakably. Then the concentration spikes 10, 50, sometimes 100 times its resting level in seconds. And that spike, that sudden flood of calcium 2 positive into an almost empty space, is not a side effect. It's the signal. Outside the cell, calcium 2 positive is just calcium 2 positive, the building material, nothing really spectacular. Inside the cell, in the cytosol, calcium 2 positive is a celebrity. Now let me introduce you to the most sophisticated communication system in the entire plant kingdom. Calcium ions have 3 specific dance moves that they use in many variations. First is the wave. It's classic, effective. Calcium ion passes into the ballroom and does a wave in a pattern that the plant recognizes, and then sends the corresponding action potential based on this pattern. Calcium ion's second move is oscillation, similar to a wave, but side by side. And its third and by far most impressive party trick is a strobe, or a flash. And calcium ions don't just do one of these moves to signal something, they do all of them. And these patterns tell a plant how to respond to vital information. It's a chemical language spoken on a molecular level. The moment Ca2 positive floods into the cytosol, a chain reaction starts. Proteins that were dormant, they wake up. Gene expression totally shifts. Hormones get released, auxins move, action potentials fire. And all of it triggered by calcium just walking through the door. The signal travels faster than the symptom. Pathogen attack, temperature change, light transition, gravity, mechanical stress, nutrient availability, every single one of these fundamental processes run through cytosolic calcium signaling. Calcium is not a building material with a side job. Calcium is the operating system. So let's bring this all the way home. It's in every feeding chart, it shows up in every deficiency guide with a picture of tip burn and a note that says add more calcium. And all that is fine as far as it goes, but now you know what it doesn't say. It doesn't say that calcium transforms into calcium 2 positive, the only form your plant can actually use, and takes a completely different path through your plant than every other nutrient. It doesn't say that calcium delivery is a transpiration problem, not a nutrient problem, that your VPD chart is your calcium delivery chart, that when your transpiration slows down, your calcium supply to new growth slows with it, regardless of what's in your reservoir. It doesn't say that your plant is burning energy around the clock to keep calcium 2 positive out of the cytosol, maintaining a concentration 10,000 times lower inside the cell than outside, so that a single stimulus can flood that space and fire a signal that travels through the entire plant in seconds. It doesn't say that cytosolic calcium is a language, that wave, oscillation, and flash are the vocabulary, that every drought response, every pathogen defense, every stomatal movement, every cloning event you've ever done ran through that system. So if that system breaks, communication breaks with it. It doesn't say that by the time you see a calcium deficiency symptom, tip burn, the necrosis, or structural failure, the signaling system was already compromised, silently, in the newest growth, before anything was visible. So here's what changes tomorrow. Well, you stop thinking about calcium as something you add and start thinking about calcium as something that you manage. Check your VPD, not just for growth optimization, but for calcium movement optimization. You maintain constant calcium for your plant, not just for building, but for communication. And you start looking at your plants differently. Next, plants build armor out of glass. I'll see you guys there.